In the third part of Precalculus Lesson 12, we look at horizontal asymptotes of rational functions. This lesson is from section 3.1 in the College Algebra textbook. We start with a definition. The line y equals c is called a horizontal asymptote of the graph of a function y equals f of x if, as x approaches negative infinity or x approaches infinity, f of x approaches c. So we have the graph of our function y equals f of x here. Note that it has a horizontal asymptote of y equals 0. So what does this mean? As x approaches negative infinity, as our graph heads to the left here, f of x approaches 0. That tells me that my y values are getting closer and closer to 0. As x approaches positive infinity, or as our graph heads to the right, f of x approaches 0, and that tells me that my y values are again getting closer and closer to 0 from the positive side. Now, let's identify the horizontal asymptote of f of x equals 1 over x plus 2. To graph this function, we could start with y equals 1 over x and shift the graph up by 2 units. Also, if you remember, f of x, or y equals 1 over x, has a horizontal asymptote of y equals 0. Think of shifting that horizontal asymptote of y equals 0 up by 2 units, and we indeed have the horizontal asymptote here for f of x equals 1 over x plus 2. We have the horizontal asymptote y equals 2. Now let's look at some instructions for identifying horizontal asymptotes. Suppose r of x equals p of x over q of x, where p and q are polynomials. If the degree of p is less than or equal to the degree of q, then r is going to have a horizontal asymptote. But before we go further, if the degree of p should happen to be greater than the degree of q, we do not have a horizontal asymptote, and that's a case we'll talk to and we'll talk about a little bit more soon, but not today. So if the degree of p is less than the degree of q, then our horizontal asymptote is simply the line y equals 0. If the degree of p is the same as the degree of q, then the horizontal asymptote is going to be the line y equals leading coefficient of p over leading coefficient of q. And let's look at some examples. First of all, we will identify the horizontal asymptote of the function f of x equals 2x plus 1 over x. We look for leading terms. So our degree of the numerator is 1, our degree of the denominator is 1. If the degree of the numerator is the same as the degree of the denominator, our horizontal asymptote will be y equals leading coefficient of the numerator, which is 2 here, over leading coefficient of the denominator, which is 1. So our horizontal asymptote for this function is y equals 2. Note that for the function f of x equals 2x plus 1 over x, we could rewrite this as 2x over x plus 1 over x, and then simplify to get f of x equals 1 over x plus 2. Well, recall, this is the same function that we graphed a few minutes ago, and we indeed did find the horizontal asymptote was y equals 2. Moving on to g of x equals x plus 3 over x squared minus 16. Here the degree of the numerator is 1. The degree of the denominator is 2. Since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be y equals 0. Now for h of x equals x squared minus 16 over x plus 3. To identify the horizontal asymptote, note the degree of the numerator is 2, the degree of the denominator is 1. Here the degree of the numerator is greater than the degree of the denominator, so as I mentioned in our instructions for finding horizontal asymptotes, there is no horizontal asymptote here. For k of x equals negative 3x squared plus 12x minus 11 over x squared minus 4x plus 4, the degree of the numerator is 2, the degree of the denominator is 2. So our horizontal asymptote will be of the form y equals leading coefficient of the numerator over leading coefficient of the denominator. We get a horizontal asymptote of y equals -3. On your own, number 3, try to find the horizontal asymptote of the rational function r of x equals 3x squared minus 4x plus 5 over 4x cubed plus 2x squared minus 3.